Hello students, so this is the next problem. A hexagonal lamina of sides 25 mm rests on one of its corners on VP. The lamina makes 45 degrees to VP. So this lamina makes indicates the surface inclinations. The diagonal passing through the corner on which it rests appears to be inclined at 30 degrees to HP. That means it is the apparent inclination given with respect to the second step. So let's see the same problem with respect to a 3D model. So this is a 3D quadrant where we have rested a hexagonal lamina rests on one of its corners on VP. So this is the VP. So in front view we are going to see it like this for the first step. So this is the hexagon and the top view is going to be just the line view. We will be able to see this edge. If this is A, this is F, this one B is not seen, C is not seen, D is seen, E is seen, F is seen. So the next condition step is the surface inclination. So the lamina makes 45 degrees to VP. So here, so this is the hexagon lamina. Now you can see in the second step, it is resting it on corner on VP, and this surface inclination is 45 degrees with respect to VP. And you can see that they are going to say, the question says that one of the diagonal is being inclined. So this is nothing but the true length of this diagonal here. So which is going to be inclined 45 degrees to VP. So in front view we are going to able to see just as the reduced surface of a hexagon. In the top view we are going to get the true length of the line, which we are going to take it from A to D. So this point is A and this point is T as shown in the 3D. So this one is a 2D layout. So this is A and this is D. So this is the first step and this is the second step for the top view. So front view is seen like this for the first two steps. So let's move to the third conditions, where this is that the on which it rests. So the diagonal passing through the corner is nothing but the AD on which it rests. So it indicates it is on resting, it is on VP. So this is the only diagonal which is going to be on VP. Rest, if you're going to consider these diagonals which is not going to be touching the VP, only this A and D is the diagonal which is inclined 45 degrees. So it appears, so when I'm going to see it in the front view, it appears as if I'm going to incline this 30 degrees with respect to HP. So we are going to take the dimensions of this and we are going to keep it in the third step. So this is the diagonal which is inclined 30 degrees to HP, and also it is having an inclination with respect to VP, which is equals to 45 degrees. So in front view we are going to able to see a hexagon which is tilted. The same hexagon has been tilted to 30 degrees. In top view also, so in top view we'll be able to see this surface view instead of the line view. The first two steps will be line view, third step will be surface view, because it is having an inclination with respect to VP as well as inclination with respect to HP. So we are going to able to get the surface view. So this is the top view what we have got, as we are going to draw it in the 2D layout. Hope you all understood with respect to the quadrant with respect to 3D model, and have a good day.